Hello, welcome. My name is Ling Zhao. Today we study the course Calculus and Vectors. Optimization problem. The topic is maximizing the length of the pole. This is application of derivative. That is graph showed. A thin rigid pole needs to be carried horizontally around the corner, join two corridors, which are 1 meter and 0.8 meter wide. Calculate the length of the longest pole that can be carried around this corner. Write the graph showed. Next, I will explain in detail. The big triangle is BAD. And the right side, there are two small triangles, like the BCE and CDF. And the pole BD. BD is constructed by BC and DC. That means there are two parts in the BD. We can set BC equal X, and CD equal Y value, right? And there are two triangles. The right triangle BCE and the right triangle CDF, right? So we know that in the triangle BCE, we know BE equal 1. DF equal 0.8 meter, right? So in the triangle BCE, we set the angle theta, and BE is the adjacent side for the theta, right? So we can list the equation. BE over X, right? The BC equal cosine theta, right? That means 1 over X equal cosine theta. This in the triangle BCE, right? Same thing for CDF. The DF is 0.8 and DF is the opposite side for theta. Okay, then the DF over Y equals sine theta. Right? So here DF over Y equals sine theta. So we can find the X. Right? Write down the X. X equal 1 over cosine theta. And Y equal DF over sine theta. Right? So write down here, this X is 1 over cosine theta. And Y equal 0.8 sine theta. Okay? We want to find the length of the pole arrow. So put the X plus Y. Right? So 1 over cosine theta plus 0.8 over sine theta. Also, we can use a negative exponent, right? So we can rewrite to arrow equal cosine theta to -1 plus 0.8 times sine theta to -1, correct? We want to find the maximum error. We want to find the maximum value for f. So we can set the derivative of error equals 0. Then how to find the derivative? And the first term is cosine theta -1, cosine theta to -1. So use power rule. So put down -1 and then cosine theta -1, -1, so -2, right? And the inner function is cosine, so its derivative is negative sine theta, right? And plus, same thing for second term. Put the -1 in the front, and then times 0.8 also, and sine theta to -2, right? Inner function is sine theta, so derivative is cosine theta, right? Just like that. And then simplify the derivative. Also, we can use the positive exponent. First term is negative times negative become positive, right? So it's sine theta. They use the derivative, denominator is cosine, become to square, right? And then second term negative, so it's minus 0.8 times cosine theta, right? Over sine square sine theta to 2, right? Okay, if the derivative equals 0, that means sine theta over cosine theta square equal 0.8 cosine theta over sine theta and square, right? Then we can use cross multiply. That means 10 cubic theta equal 0.8, right? It's cross multiply in sine cubic equal 0.8 times cosine cubic. Okay, then the 10 cubic theta equal 0.8. Then we can find the 10 theta. That's 0.8 square root, right? And we know this theta is less than 180 degree, right? So just take the positive, right? Just take is 0.9283. So just take the positive and still at the first quadrant, right? The first quadrant. So just like that. So theta equal 10 inverse 10 equal 0.9283. Actually, yes, the value is 0.748 ID. Okay, only one solution because theta is less than 90 degree. Then error equal 1 over cosine theta. Theta is 0.748 and plus 0.8 over sine 0.748. Finally, AG can get this. Answer is about 2.56 meter. Okay. So the maximum value of the length of the pole is 2.56 meter when the angle theta is about 0.748 RAD. Is the final answer. Okay. That's the end for the show of the solution. Please subscribe my channel. Easy math, just easy and funny. Next is an interesting video. Thank you for watching. See you.